Okay, that's the keyboard and the wheels, but let's look at these. On the back there's a very nice range of jacks, CV out and in. Now this refers to the CV of the keyboard. Trigger out and in. You might refer to these as gate out and in on other synthesizers. Kind of means the same thing. A lot of early synthesizers, very early synthesizers, had separate gate and triggers. Now the trigger was a very brief pulse as soon as you hit the key. The gate was a duration of however long you're holding the key down. Let go, the gate stops. It proved to be fairly easy to derive a trigger pulse, which triggers the envelopes, from the gate. You just look for the leading edge transition and derive a little trigger pulse from it. So you can get a trigger from a gate signal. This says trigger. It can accept a trigger from another device, or it can put its own triggers out, say from the arpeggiator, or every time you hit a key, out to another device. As was the case back in the 80s, 70s, those days, standards weren't necessarily standard. I've mentioned that there was a CV standard of 1 volt per octave. There was also another standard, 1 volt, or volts per hertz. So to double the amount of, to go up a certain amount of hertz in frequency, you go up 1 volt. Now one's logarithmic, one's linear, they're scaled slightly differently. Now those standards competed. Similarly, we had a competing standard with triggers and gates. Which way does the gate go? Well, a lot of Roland synthesizers had positive going gates where the gate was 0 until you pressed a key and it jumped up to 10 or 15 volts or whatever the device is. The competing standard was negative going, so it's like closing a switch. So the gate signal is high and then you drop it down to 0 when you press the key. Here we've got a nice switch where I can switch it to either of those. I can use either standard. Very nice. So we've got CV out from the keyboard, CV in from something else, for example another sequencer or another synthesizer, to control this. Same with the trigger out or gate in and out. Switchable polarity. VCO FM in. Now what does this do? If this is controlling the frequencies of the VCOs, the keyboard or the CV in is controlling the frequency of the VCOs, what's this doing? VCO FM in will also control the frequencies of the VCOs. However, you may not realise, if this is 1 volts per octave, this is volts per hertz. So you can use, for example, an MS-10 or an MS-20 or an SQ-10 or some of the Yamaha synths which were also volts per hertz. You can use a volts per hertz standard input here, and it would make sense musically here. I mean, this will modulate and this will modulate the frequency. They will both do that kind of job, but this won't be musically meaningful. If you put a volts per hertz input on here, it will still modulate it up and down, but it won't be. It will be non-linear. Well, it will be linear when it's expecting non-linear, and vice versa for this. So it's good to have both. You've got volts per octave CV in to modulate the frequency of the oscillators here, volts per hertz CV in to modulate the frequencies of the oscillators here. And similar with the VCF, you've got a volts per hertz center frequency modulation input, voltage input here. Portamento, which is a switch, you can switch the portamento on or off. Very wide. But you can switch it on and off here with a foot switch. Arpeggiate trigger in. Well, this will trigger the arpeggiator instead of having modulation generator 2 tied up doing this. Those are the input outputs: mod gens, wheels, keyboard, envelope generators. Those are all ways of generating control voltages to control either the things that modify or treat or alter the sound, or control the things that actually generate the sound. So in our next episode, let's look at the VCOs. Thank you, goodbye.